honor to be introducing our first speaker today, Lucy Creighton, everybody. Lucy is from Murphy, North Carolina, and while at Warren Wilson, she's worked on the athletics crew and then more recently on the Bio or conservation biology sub-crew of the Bio-ENS crew. She's also a student athlete participating in cross country, soccer, and swimming for all of her time here at Warren Wilson, including being the captain, so that's amazing. And for the last couple of years, she has spent her last 2 summers out in the highlands of Colorado chasing salamanders around as a part of an internship that she's been doing there for the last few years at Rumble, the Rocky Mountain Biological Laboratory. And her NSUR's project stems from this research, but it is only but a tiny snippet of the work that she's done up there for the last 2 years. You're not going to hear about this really awesome feeding experiment that she did to find out whether these salamanders eat an invasive caddisfly. You should ask her about that at the end. And you're not going to get to hear about whether or not these salamanders glow, which you should also ask her about at the end. But what you will hear about is her analysis of a long-term data set, working with these animals to answer a really interesting and really important conservation question about the impact of invasive species. Lucy also presented this research last year at a national conference, the annual meeting of the Wildlife Society, where it was very well received, and you're in for a treat. So please welcome Lucy Creighton.
Thank you, Olia, for that wonderful introduction. And with that, I'll be hopping right into it. This is the effects of a range-shifting caddisfly on salamander body condition. Okay. Human-caused climate change is happening. We know that it is going to be affecting communities, but a lot less is known about the exact mechanisms of how that change is going to occur in communities and ecosystems themselves. And one way that we're expecting to see these communities change, and already are seeing these communities change, is through climate-driven range expansion, where species are beginning to expand their range just based on what, what habitats have become more hospitable to them. And you can broadly break range expansions down into 2 categories: geographic range expansion and elevational range expansion. 9-banded armadillos are an excellent example of geographic range expansion. They began in the southernmost part of the US and they've since spread to the entire southeast. Even this particular map is a little outdated. It was made in 2011, and since then we now see 9-banded armadillos as far north as Virginia and southern Indiana. Similarly, in the European Alps, we've seen the elevational range expansion of several different species of butterfly and a few species of moths, with the species moving up in elevation from the lowlands based on climatic changes, particularly temperature and solar radiation. And the present communities in these areas, the existing communities, are still there when the species are moving into, when these novel species are range expanding into new areas. And what it's doing is creating novel communities that did not evolve together and are now experiencing all of these new interactions. And it's really, really difficult to study exactly how these novel communities work if you don't have a wealth of baseline data about the existing community. And that's relatively rare. Long-term data sets of that kind are relatively rare. And I got the absolute privilege to be able to work at a research field station where they have several of these long-term data sets. I spent the last 2 summers, as Olia said, at the Rocky Mountain Biological Research Laboratory, fondly known as Rumble, in Gothic, Colorado. And I was working with Dr. Howard Whiteman, who's been doing research there since 1990. And Howard works at a place called the Mexican Cut Nature Preserve, which is a high elevation pond complex of 60 plus ponds. It's located at just over 11,000 feet above sea level. And it is owned by the Nature Conservancy, and Rumble just manages it as a field site. And there's actually, at the Mexican Cut, there are two different long-term data sets, long-term research projects happening. The first was started in 1988 by Dr. Scott Wissinger into the aquatic invertebrate communities, and the second was started by Howard in 1990 looking at Arizona tiger salamanders. And Arizona tiger salamanders will be the focal species of this study. They're the top predators in these ponds. They eat pretty much everything. They're, due to the super harsh winter conditions up at the Mexican Cut, they are super long-lived, very slow growing, and they have two unique morphs as adults. One is a fully aquatic pedomorph, which essentially just means that they retain their larval characteristics into sexual maturity, and the other is a semi-aquatic metamorph, which somewhat similar to the spotted salamanders around here. They spend about half of their year underground. And in 2016, researchers at the Cut first reported Nematolis hostilis, which is a native Colorado caddisfly, but it's never been seen, before pre-2016, it had never been seen at elevations higher than 10,000 feet. And interestingly enough, this was not the first range expansion of a caddisfly into the Mexican Cut Nature Preserve, but there's several things that make this particular species unique. Namely, it became established in both the semi-permanent and permanent ponds up at the Mexican Cut. They're one of the more aggressive caddisfly species, so they were moving all around a lot more in the ponds than some of the others, and they experienced a huge population boom in 2021. Finally, they have a pretty big difference in their phenology. N. hostilis overwinters as active larvae instead of as eggs, which is what all of the other caddisfly species up there do. So that means that they are moving around in their little cases like this in the late fall and early spring, times when the ponds are iced over but not fully frozen, and also times when pedomorphic salamanders have not had as abundant prey. And essentially, preliminary research has shown that the pedomorphic salamanders are predating on this caddisfly to some extent. Which just kind of brings me into my research question, which was, did salamander body condition improve after N. hostilis arrived at the Cut? I'll be discussing this body condition variable more once I get to my methods. But essentially what I was predicting was, because they have this new food source in the late fall and early winter, the salamanders will have better body condition going into the summers and won't lose as much weight, which will increase just their overall health for the most part. I would like to give a quick overview of the general data collection that happens at the Cut so you can understand where I was getting the data that I ended up analyzing. First, we spend a fair amount of time just catching salamanders out of the ponds. That's usually a couple hours in the morning after we hike in. From there, we bring the salamanders back to a weather port, and it is a mark recapture data set, so we check to see if they have either toe clips or a passive integrated transponder, also called a pit tag, which essentially just lets us track individuals over the course of their life. Once we've checked whether they're a recapture or not, we take a variety of different qualitative and quantitative measurements. We take their snout to vent length and total length as shown here. We weigh them. We also record what morph they are, what their sex is, their cloacal condition, and for pedomorphs we also take into account gill health. If we have a larval salamander that we can determine a cohort age for, we'll also include that, and all of that data is going into an Access database that's been maintained since the start of the project, which is how I was able to take, calculate numeric representation of body condition as the mass divided by the snout to vent length, which is essentially their weight divided by the tip of their nose down to the bottom of their cloaca. And that just gives you a numeric representation of how chunky the salamanders are, more or less. So I calculated body condition for the entire data set, and then subsetted out 12 years of data, 4 years before the N. hustulus arrived at the cut, 4 years during, and 4 years after. And this differentiation between during and after was to try to account for that big population boom that they experienced in 2021. From there, I used RStudio to run a generalized linear mixed effects model, essentially just looking at a comparison of body condition based on caddisfly establishment. I also included several other fixed variables, including morph, sex, the pond, and season day. To explain that season day variable a little bit more, that's essentially just how long our season ran. So day 1 is the first day that we began data collection until whatever day we happen to end. Usually ends up being between 75 and 100 days total. And lastly, to account for multiple captures of the same individual, because we are capturing the same individuals over and over again over the course of a season, my random factor here was individual ID. And that was just to account for those multiple captures. Which brings me to my results. In total, the final data set included 4,500 individuals with just over 14,000 observations. I organized the results in this table here, and just to orient you quickly, the variable is what the fixed variable is. The p-value is whether or not that variable was significant at a 95% confidence interval. And this trend is how was the body condition based on, like, what exactly was significant for body condition. And I'll be coming back to the caddisfly establishment, which was kind of the big reveal there, but just to briefly go through these other fixed variables. 3 out of my 4 additional fixed variables were significant, with pedomorphs having better body condition than larval salamanders, females having better body condition than males or immature salamanders, and pond 12, one of our 3 permanent ponds, having the best body condition, pond 1 having the worst, and pond 5 being somewhere in between the 2. I did find, interestingly enough, that season day was not significant, which essentially just means that their body condition was not changing significantly over the course of the summer. They weren't getting a lot fatter with time over additional, they were not getting fatter over the course of the summer with additional invertebrates in the ponds. Which brings us all the way back around to caddisfly establishment. This is the big one. The graph shown here is the model means plotted with a 95% confidence interval. Along the x-axis, we have caddisfly establishment with our before, during, and after categories, and then our y-axis is the body condition, which in this case is grams times millimeters multiplied by 100, just to make the numbers a little easier to work with. And it's a little bit difficult in this to really see the trends that we saw in the model. So if you restrict the y-axis down a little bit, we see that salamander body condition was significantly better before N. hustulus arrived at the cut. And it became significantly worse during that establishment period, and is just starting to recover as we move into this after establishment or post-establishment stage. So at the end of the day, in answer to my question, did salamander body condition improve after N. hustulus arrived at the cut? The answer is no, surprisingly enough. And in fact, it got worse. However, there's a few things that we should keep in mind when thinking about this particular result, is that, namely, this is a correlational study. It's entirely possible that the caddisfly caddisfly did have a negative effect on salamander body condition, but it's also equally possible that this was a different variable that I wasn't able to account for in my model, maybe salamander population densities, things like that. And something else to keep in mind is that it could be just a snapshot of a larger natural cycle in body condition. This is a graph that was created in the summer of 2022. It is the change in body condition over time, starting in 1990 and ending in 2023. And as you can see, there's a lot of variability and just seasonal year-to-year change and fluctuations in body condition for each of the 3 ponds. So essentially, while my data was statistically significant, it's entirely possible that it was not ecologically significant in these pond systems. And at the end of the day, ecological significance is what this study and others are trying to prove and trying to look at in these novel communities in particular. A few things to note. Balick et al. Did find that N. hostilis at the cut caused significant changes in caddisfly species abundance and relative contribution in ecosystem processes, specifically nutrient cycling. So it's possible that in 10 years, if you were to rerun this same data set, you might see differences, more significant, or more solidly ecologically significant differences just due to changes in this nutrient cycling. And similarly, across the world in Finland, and Tao et al. Found that climate change has had a significant effect on the relative position of species within climatic niches. So within the ponds, within all of these different niche area, with all the different niches within the ponds, we could see a shift in where all of the species are playing their role, which could also affect salamander body condition in the future. And all of that to say that essentially we are finding evidence that ecologically significant changes are happening due to climate change and due to these climate-driven range expansions. Just in a broad sense, which definitely puts the results of my own study into more context and suggests that there might be more ecological significance than it might seem at the moment. Finally, I would like to just do a couple of acknowledgements. A huge thank you to Olya Melenkaya and Howard Whiteman, who are my mentors and advisors. Thank you to my committee, Mark Brenner and Pat Siccato, for all of their feedback. Huge shout out to Holly Rosin for all of her help with our studio. A gigantic thank you to all of the Mexican Cut salamander and bug crews from 2012 to 2023 for their data collection. Thank you to the Nature Conservancy for allowing researchers to work with the Cut, and Rumble for their incredible undergraduate program and their financial support. Finally, thank you also to all of my family and friends who've listened to me rant about salamanders a lot. Reference this slide, and if anyone has any questions, I would be happy to field them. Yeah.
Has anybody done a study to see whether these invading caddisflies are less nutritious or more nutritious than the ones that are living there?
So that's actually kind of our next step. There have been some studies in the past looking at nutritional value of a bunch of different invertebrates, including the caddisflies, but we haven't done a comparison of the current caddisflies that are there and this new species that's kind of in the future of what's going to be happening up there.
I'm curious about the caddisfly. Do you know what kind of diet or functional food they go to? Because N. hostilis makes me think they might be predators.
Yeah, I believe, if I'm remembering this correctly, they are primarily shredders, if I'm remembering correctly. Although they do cannibalize each other in addition to eating other invertebrates as well. So they kind of were like, they kind of just there. When I did the feeding experiment 2 summers ago, I had to have all of my controls were essentially, they were only caddisflies to make sure I could account for cannibalization of each other, essentially.
Great talk. So my first question, it looks like there is sexual dimorphism, so differences between male and female. Can you
Yes.
speak kind of first to those? But then secondly, I was wondering if, your research group that you were working with, if you chatted about any sort of climatic effects. I mean, of course, the umbrella climate change, right? But particularly maybe cyclical events in regards to winter or anything that could have been correlated with the data.
Yeah. So there is sexual dimorphism between the two, especially in terms of the body condition. Not 100% sure why that is. Maybe just like a matter of the females need to have better body condition in order to like produce eggs, et cetera, et cetera. Probably related to that. I'm not 100% sure. I can't speak to that super well. There's a lot of climate research happening at this site right now. One of the things that we're doing is implanting temperature data loggers into the salamanders to look at changes, internal body changes, specifically for stuff like that, of like, have the winters been getting warmer, and that type of thing, and how is that affecting the salamanders. Really cool stuff to come out of that. We found out that they do freeze solid. Additionally, some of the weather data that we're finding, that right before that big population boom in Hastilis that I talked about, there were a series of 2 or 3 really mild winters. So we're kind of keeping track of things like that. I don't know if that really answers your question.
Absolutely.
Yeah.
Thank you.
I'm gonna take the bait, because we need to know
Yeah.
about glowing salamanders.
Yes. So I actually had a second foraging experiment planned for last summer, and we got a bit distracted, and that foraging experiment never happened because we found out that these salamanders biofluoresce. So really, really crazy excitement. We're working on data analysis of that right now. Also seeing some potential sexual dimorphism there in biofluorescence. Really crazy stuff. I probably should have included another slide at the end that had a glowing salamander on it, but yeah. Sorry, I'll go all the way up top. Priscilla's had her hand up.
In the data set, I know, so you mentioned and you showed us the graph by year of the salamander body type. In the data set, is there other recorded data about like environmental factors that could potentially be examined to like look at the weather and look at the winter pattern? Like, is there enough data to do analysis on that and compare that to your caddisfly analysis?
So there used to be a weather station that was taking all of that data up at the cut. It's very harsh winters up there, and eventually it did shut down and break down. So we have some weather data, and we've been putting out more and more temperature data loggers specifically in the ponds, buried underground, at surface level, etc. So I think at some point we will have more of that to give, but at the moment we're not as much.
What color do they fluoresce?
Green. Bright green. Yeah.
One question.
No.
Whoever. Yeah.
I'm just visiting. I noticed that plot of body condition versus year. It looked like it was a negative trend for all 3 ponds over
Yeah.
time, and I wanted to know what your opinion was about that.
Yeah, so I was not, when I created that graph, I was not specifically, we didn't find any significant trend, but it does seem to be trending downward. Interestingly enough, more recently, Howard has done a broader analysis on just general life history at the cut through the years, which goes up to 2008, I believe, is the cutoff for that, 1980 to 2008. And they did find that there was significantly, one moment please, buffering. They found that there was a significant increase in body condition, which is opposite of this graph and opposite of what I found through my data. So I haven't had a chance to sit down and talk to him more about that, but that's kind of, I don't know if that answers your